Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out some practice problems that should closely mirror what you'll see on the Arithmetic Reasoning Subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB, so as you take this practice test, it's in your best interest to not make use of those resources. Similarly, in order to get the most out of this video, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a rule of thumb, I like to say that you should take at least 10 of these practice tests in order to get a better feel for the ASVAB. So don't think that by just watching this one video, you're going to see all the different potential types of questions on the ASVAB. Again, I recommend that you watch at least 10 of them. Finally, I want to mention that in the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamp, there's going to be a topic that's the question's testing, as well as a link to a video where I discuss that topic in greater detail. So if at any point you get stuck on one of these questions, just check the description of this video. There you'll find links to those additional resources. So all that being said, let's go ahead and get started with this practice test. All right, this first question says, how many cars are needed to carpool 14 friends if each car can safely transport 5 people? So this is a simple long division problem. So we're going to take 14 and divide it by 5. Again, fractions can be treated as fractions or as long division. If you treat them as long division, you read them like this: 14 divided by 5. And by working this out, we'll quickly figure out how many cars we need to transport your 14 friends. So the first thing I'm asking myself to do this long division is, how many times does 5 go into 1? It doesn't. How many times does 5 go into 14 without going over? That's going to be 2 times, given that 5 times 2 is 10. 14 minus 10 is 4. And at this point, we have to know that we can place a decimal here as well as some 0 placeholders after 14 in order to keep performing this long division. Once you place that decimal there, you can bring it up right here. And this is going to enable us to drop down one of these zeros, which makes the question, how many times does 5 go into 40? Of course, that's going to be 8 times, given that 5 times 8 is 40, and 40 minus 40 is 0. So to answer this question, it would take 2.8 cars to transport 14 people if 5 people can safely fit in each car. Given that there's no such thing as 0.8 of a car, that means you would need 3 cars to safely transport everyone. Okay, so that's that one. Just a simple case of long division. I have a video in which I show you how to add these 0 placeholders to perform long division. So if you struggled with what I did there, just check out that video. Again, most videos on long division on YouTube don't really go this in depth with long division. They're very simple. But in my video, I show you all you need to know to be able to perform this long division like this. All right, so that's that one. Let's go ahead and move on to number 2. Number 2 says, on a class trip with 40 students, 14 are male. What percentage of the class is female? Okay, so the very first thing we want to do is find out how many female students are in the class. So I'm going to take 40, which is the total number of students in the class, and subtract 14 from it, which is the number of male students in the class. And by doing that, we'll figure out how many females are in the class. That's not the answer to the question, but that's going to get us one step closer. So right here we have 0 minus 4, which we can't do. We're going to have to borrow from here. This is going to become a 3, and this is going to become 10. 10 minus 4 is 6, and 3 minus 1 is 2. So again, there are 26 females in the class and 14 males in the class for a total of 40 students in the class. Again, 26 plus 14 is 40. Now, in order to determine what percentage of the class is female, again, we're going to use a fraction to represent that, notably 26 over 40. And as you saw already in this video, we can do long division to convert this fraction into a decimal. And prior to doing that, though, we can actually reduce this fraction to make that math a little bit easier. More specifically, we can reduce 26 over 40 by dividing 26 as well as 40 by a common factor of 2. And you should be able to do this in your head. This isn't too difficult. 40 divided by 2 is 20, of course. 26 divided by 2, well, 2 goes into 2 one time, 2 goes into 6 3 times. And now we can go ahead and regard this fraction, notably 13 over 20, as long division. So again, we read this as 13 divided by 20. And as we did above, we start by asking ourselves, how many times does 20 go into 1? It doesn't. How many times does 20 go into 13? It doesn't. In light of that, we have to place a decimal here and a 0 placeholder. Again, once you place that decimal, just go ahead and bring it up in place. Now the question is, how many times does 20 go into 130? Well, this isn't as difficult as it seems. 20 times 7 would be 140. 20 times 6 would be 120. Again, we can't go over that 130, so this is going to be 6. Again, 20 times 6 is 120, so we'll subtract that out. 130 minus 120 is 10. And once you bring up this decimal, you can disregard it as you perform this subtraction down here. And again, we can add another 0 placeholder as needed, which we can then drop down. Now the question is, how many times does 20 go into 100? 20 times 5, of course, is 100. 100 minus 100 is 0. And so we can see that 13 over 20 is the same as 0.65. 0.65 can be written in as a percent by multiplying it by 100. Whenever you multiply something by a power of 10, which is 10, 100, 1,000, 10,000, and so on, you just take this decimal and shift it to the right according to how many zeros there are in that power of 10. In 100, there are 2 zeros, so we're going to take this decimal in 0.65 and shift it 2 times to the right to make this 65%, which is D. Okay, so that's that one. Again, some simple arithmetic to get this one right. All right, number 3 says Mike pays $2.79 for coffee every weekday morning on his way to work. On Saturdays, he goes to visit his mother and takes her out to her favorite coffee shop where he spends $7.83 for 2 coffees. How much does he spend per week for coffee? So again, we know for every weekday, which is Monday, Tuesday, Wednesday, Thursday, Friday, that is 5 days, he spends $2.79. Whereas on Saturday, which is another day, he spends $7.83. So we're going to have to take $2.79, multiply it by 5, and then add it to $7.83. For this problem, we're just working with some simple decimals. So let's go ahead and do that. We got 2.79 times 5. When you're multiplying decimals, the trick is to eliminate the decimals as you do your arithmetic. In order to eliminate the decimal in 279, you just shift the decimal 2 places to the right. to make 2.79279. We're going to multiply that by 5. And once we're done working this out, we're going to take those two decimals that we shifted to the right over here and shift them back into the left. So 9 times 5 is 45, so we're going to drop down a 5 and carry a 4. 7 times 5 is 35, 36, 37, 38, 39. Carry a 3. 5 times 2 is 10, plus 3 is 13. Take our two decimals that we moved to the right and shift them back into the left. So we can see that for those 5 days of the week, he spends a total of $13.95 on coffee. All we do is have to take $13.95 and add $7.83 to it, and that will give us the total that he spends on coffee for the 5 weekdays plus Saturday. So let's go ahead and do this. When you add decimals, you don't have to shift the decimal place in any way. You simply just drop it down in place, which I'm going to do right now. And now we're just doing simple addition. 5 plus 3 is 8. 9 plus 8 is 17, so we got to carry a 1. 7 plus 3 is 10, plus 1 is 11. Again, we got to carry a 1. 1 plus 1 is 2. So in total, for the 5 days that he gets coffee in the morning, as well as the Saturday he goes out for coffee with his mom, he spends $21.78, which is D. Okay, so you do have to get comfortable working with decimals for the ASVAB. Again, in the description of this video, there's going to be a link to a video where I discuss decimals for about an hour. Okay, so that's that one. All right, number 4 says, Jenna and Steph are living together and have agreed to split half of all living costs. Rent for their apartment is $970. The water bill is $52. The gas bill is $25, while the electric bill is $66. What is each girl's total monthly expenses for living in the apartment? So the most efficient way to solve this problem is to add up all their bills and then divide that total by 2. So let's go ahead and do that. Again, we know they pay $970 for rent, $52 for water, $25 for gas, and $66 for electric. So let's go ahead and add these up. We have 0 plus 2, which is 2. 5 plus 2 is, well, let's do 5 plus 6, which is 11, plus 2 is 13. So we're going to carry a 1. 7 plus 1 is 8, plus 2 is 10. 10 plus 5 plus 6, which is 11, is 21. So we're going to drop down a 1 and carry a 2. 9 plus 2 is 9, 10, 11. So in total, they spend $1,113 for their monthly expenses. We want to know how much each of them pays, so we're going to take that 1113 and divide it by 2. Okay, and again, you do have to be proficient at long division for the ASVAB. That said, once you get the hang of it, it's not too difficult. We're going to start by asking ourselves, how many times does 2 go into 1? It doesn't. How many times does 2 go into 11 without going over? That's going to be 5 times, given that 5 times 2 is 10. 11 minus 10 is 1, and we get to drop down this 1 now. Again, the question is, how many times does 2 go into 11? That's going to be 5, of course, given that 5 times 2 is 10. 11 minus 10 is 1. Now we're going to drop down this 3 all the way down, and the question becomes, how many times does 2 go into 13 without going over? Of course, that's going to be 6 times. 2 times 6 is 12. 13 minus 12 is 1. If you look at your answer choices, you can see that this was the total that both of them paid, so we know that's not correct. And the only answer choice with a 6 in the units place is D. So without doing any more work, you could say that the answer is D pretty confidently. That said, let's keep working out this long division since it's good practice. So in this case, again, we're going to have to add a decimal and a couple 0 placeholders, maybe 1, which will enable us to bring the decimal up here and drop down the 0 here. And the question becomes, how many times does 2 go into 10? Of course, that's 5, given that 2 times 5 is 10. And since we hit a 0 here, we know we're done working this out. And as we can see, that is 556.50, which is in fact D. Okay, so that's that one. All right, number 5 says, Hugh is struggling in his history class. His last 5 grades on test were 67, 72, 63, 77, and 59. On the next test, he studies hard but gets a 75. What is his average? Okay, so to find averages or means, you sum up all the numbers you're given and you divide by how many numbers there are. So that looks like this. We're going to sum up all the numbers that we're given. So we have 67 plus 72 plus 63 plus 77 plus 59 plus 75. And we're going to divide by how many numbers there are. There are 1, 2, 3, 4, 5, 6. Okay, and by working this out, we'll know what his average in the class is. You will see an average problem on the ASVAB, and whenever you have a bunch of numbers in the numerator here, it's a good idea to add them vertically like this, so you don't make any mistakes. Although this is where you're likely to make a mistake on the test, so take your time as you add these up. Again, I'm going to do this probably differently than how you do it because I like to combine things that are even. Okay, make sure we got them written down correctly. All right, so we're starting in this right-hand column. I'm going to do 7 plus 3 since I know that's 10. Then I'm going to do 7 plus 9, which is 16. Then I'm going to do 5 plus 2, which is 7. So we have 10 plus 16, which is 26. And then we'll just add 7 to that. 7 plus 6 is going to be 13. Carry a 1. 2 plus 1 is 3. So we're going to drop down a 3 and carry a 3. Again, I like to do the math such that it's a little bit easier to do. I know 7 plus 7 plus 7 is 21. I know 6 and 6 is 12. And I know 5 and 3 is 8. So let's go ahead and work that out. 8 plus 2 is 10, plus 1 is 11. So we're going to drop down a 1 and carry a 1. 2 plus 1 is 3, plus 1 is 4. So this is 41. Okay, so we can replace the numerator with 413 divided by 6. Again, you can treat this as a fraction or long division. In this case, we have to treat it as long division. So we're going to read it as 413 divided by 6. And by working this out, we'll figure out what the answer is. And so we start by asking ourselves, how many times does 6 go into 4? It doesn't. How many times does 6 go into 41 without going over? 6 times 7 is 42, whereas 6 times 6 is 36. So we know this is going to be 6. Again, 6 times 6 is 36. And right now we can go ahead and eliminate a few of these answers. Specifically, we can eliminate the ones that start with the 7. That said, we have to keep working this out to figure out whether A or D is correct. So let's just go ahead and work this out. 41 minus 36 is going to be 5. And we can drop down this 3 now. 6 times 9 would be 54, which is too big, so we know this has to be 8. And 6 times 8 is going to be 48. Okay, and right now we know our answer is going to be 68 point something. So without doing any more work, you can say that the answer is A. That said, for practice, let's keep working this out. 53 minus 48 is going to be, well, 48, 49, 50, 51, 52, 53, 5. And again, now we can add our decimal and zeros as needed. I'm just going to tack on 3. And we can drop this one down. And the question becomes, and again, once you add that decimal, you can bring it up now. And the question becomes, how many times does 6 go into 50 without going over? As we just saw, that's going to be 8, given that 6 times 8 is 48. 50 minus 48 is 2. And we're going to bring down this 0 now. And the question becomes, how many times does 6 go into 20 without going over? That's got to be 3, given that 6 times 3 is 18. Subtract. And this is just going to be 0.3333 if you work it out. And it looks like they rounded it down just to be 68.8. And you'll find that that's the case on the ASVAB. Sometimes they'll take an answer choice and just round it to the 10th place. Okay, so that's that one. All right, number 6 says Tammy is 17 years older than Gina. Gina is 3 years younger than Rochelle. If the sum of their ages is 77, how old is Gina? Okay, so this is an age problem, and it's not as difficult as you think. As long as you can translate this word problem into a simple algebraic expression that will help you figure out how old each of these people are. So the way I like to think about these is like this. Tammy's age is reference to Gina's age. Gina's age is reference to Rochelle. Rochelle is not reference to anyone else's age. So I'm going to say Rochelle, and then I'm going to put an R up here so we know that's her. Rochelle is X years old. Okay? And we want to know what, we know the sum of their ages is 77, so we're going to put a plus there. Again, we know Gina is 3 years younger than Rochelle. If Rochelle's X, that means Gina is X minus 3 years old. And again, this X minus 3 is Gina's age. Again, the sum of their ages is 77, so we're going to add another plus. And then finally, we know Tammy is 17 years older than Gina. So that looks like this. Again, Gina is X minus 3. We can put that in parentheses if we want. But Tammy is 17 years older than that. Again, this is Tammy here. And we know the sum of all their ages is 77. All we do is have to work this out to figure out what X is, and then we'll be able to figure out how old Gina is. So let's go ahead and do that. I just put those parentheses there for emphasis. We can actually remove them now if we want. So let's just go ahead and simplify this. Again, I'm just going to remove these parentheses as my first step, but you can skip that if you want. We have X plus X minus 3 plus X minus 3 plus 17 equals 77. Let's combine like terms. We have X, X, and X there. So that's 3X. Then we have negative 3, and 17. 17 minus 3 is 17, 16, 15, 14. Minus 3 more is going to be 14, 13, 12, 11. So this becomes 3x plus 11 equals 77. Again, we're solving for x at this point, which will tell us how old Rochelle is. And then we can use some basic algebra to figure out how old Gina is. So to get x by itself, I'm first going to subtract 11 from both sides. This will cross out here, leaving me with just 3x on this side. 77 minus 11 is pretty easy to do. 7 minus 1 is 6. 7 minus 1 is 6. Again, we're trying to get x by itself, so we're going to divide both sides by 3 as our next step. This is going to cross out and leave us with x equals 66 over 3 is pretty easy to do mentally. 6 divided by 3 is 2. 6 divided by 3 is 2. So again, x referred to Rochelle's age. That's not what this question's asking. This question is asking how old is Gina. We know Gina's age can be determined by this formula. Again, Gina's age is x minus 3. We solve for x, so let's just plug it in. Gina is 22 minus 3. That's going to be 22, 21, 20, 19. So Gina is 19 years old. Okay, so kind of difficult to get used to these. Again, when they reference people's ages to other people, just go and start by writing the first person's age with an X, and then write your expression accordingly. All right, let's go ahead and move on to number 7. Number 7 says Cindy's parking garage charges $3.50 for weekday parking, and weekends are half price. If Cindy parked in the garage 20 times per month, and 3 of these days were weekend days, how much would she spend per month on parking? This one's going to require a few steps. First, we have to realize that 20 minus 3 is 17. So she parked in the garage on 17 weekdays and 3 weekend days. We're only given the cost of parking for weekday parking, which is $3.50. So we can figure out pretty easily how much she paid for weekday parking. That said, according to the problem, weekend parking is half the amount of weekday parking. So we're going to have to do some arithmetic to figure out what that amount is. So we're going to take $3.50 and multiply it by 1/2, which is the same as 0.5 in decimal form. Again, 1/2 is the same as 0.5. If you were to do the long division to convert this to decimal, that's what you would get. But that said, we're now working out a multiplication problem involving decimals. And as we previously saw in this video, we can do these pretty easily by shifting the decimals to the right to get rid of the decimals temporarily. So I'm going to shift the decimal in 350 2 times to the right, and in 0.5 1 time to the right. So in total, I shifted the decimal place 3 times. 2 in this top number, 1 in this bottom number, and this becomes 350 times 5 with no decimals. And once I work this out, I'm going to take those 3 decimal places that I shifted to the right and shift them back into the left. So let's just work this out. This is 5 times 0, which is 0. 5 times 5, which is 25, carry a 2. 3 times 5 is 15, 16, 17. Shift our 3 decimals back into the left. 1, 2, 3. So we can see that half of 350 is 175. Okay, so again, she parked in the garage for 17 weekdays. So that's going to be 350 times 17 and 3 weekends. So 3 weekend days. So that's going to be 175 times 3. Once we work out this arithmetic, we'll add those 2 results together, and that will tell us how much she spent for parking in total. Again, We're doing multiplication involving decimals, so I like to rewrite these decimals as whole numbers. Let's do them one at a time so we don't get confused. I'm going to shift the decimal in 3.50 2 times to the right to make it 350 times 17, albeit with 2 decimals to shift back into the left at the end. And let's go ahead and do that. We got 7 times 0, which is 0. 7 times 5 is 35, so we're going to drop down a 5 and carry a 3. 7 times 3 is 21, 22, 20, 21, 22, 23, 24. Again, since we're starting multiplication with this 1, we have to bring in a 0 placeholder before we do anything else. 1 times 0 is 0. 1 times 5 is 5. 1 times 3 is 3. Let's go ahead and add these. 0 plus 0 is 0. 5 plus 0 is 5. 4 plus 5 is 9. 2 plus 3 is 5. Bring in our 2 decimals. 1, 2. So we can see that for weekday parking, she spent $59.50. Let's do the same thing here. Let's take that decimal place in 1.75 and shift it 2 times to the right. So this becomes 175 times 3. And once we get done working this out, we'll shift that decimal place 2 times to the left. 5 times 3 is 15. Carry a 1. 7 times 3 is 21. Plus 1 is 22. Carry a 2. 1 times 3 is 3 plus 2 is 5. Shift our 2 decimals to the left. 1, 2. So we can see that she spent $5.25 to park in the garage on the weekends. All we do is have to add these two together. So this becomes $59.50 plus $5.25. Again, we're adding decimals now, as we've seen in this video already. We just drop that decimal in place and treat this like normal division or normal addition. 0 plus 5 is 5. 5 plus 2 is 7. 9 plus 5 is 14. Carry a 1. 5 plus 1 is 6. So in total, she spent $64.75 for parking, including for weekday and weekend parking. So that's going to be B, as we can see. A lot of arithmetic to this one. You're going to see that on the arithmetic reasoning subtest. All right, number 8 says, Trade drives an average of 36 miles per day. How many days will it take him to drive 3,240 miles? So again, this is just simple arithmetic here. We're going to do 3,240 and divide that by 36. Okay, again, we're going to regard this as long division. Notably, 3,240 divided by 36. And the question becomes, how many times does 36 go into 3? It doesn't. How many times does 36 go into 32? It doesn't. How many times does 36 go into 324 without going over? It does, but we're going to use our answer choices to kind of guide our work here. It's either going to be 7, 6, 9, or 8. And let's think about it. 30 times, or 3 times 9 would be 27. So 36 times 9 is going to be probably over 324. 3 times 8 would be 24. Therefore, 36 times 8 is going to be close to 324. So let's go ahead and see if 36 times 82 will give us 3,240. So let's do that off to the side. We have 82 times 36. 6 times 2 is 12. Carry a 1. 8 times 6 is 48. 49. Before we start multiplication with this 3, we have to bring in a 0 placeholder. 3 times 2 is 6. 8 times 3 is 24. 2 plus 0 is 2. 9 plus 6 is 15. Carry 1. 4 plus 4 is 8 plus 1 is 9. And then 2 plus nothing is 2. So it looks like 90 may work. I might have misspoke there when I said 36 times or 30 times 9 would be too big. So let's try 90 now. We have 36 times 90. 6 times 0 is 0. 3 times 0 is 0. Let's add a 0 placeholder now that we start multiplication with this 9. 9 times 6 is 54, so we're going to carry a 5. 9 times 3 is 27. 28, 29, 30, 31, 32. Nothing plus 3,240 is 3,240. So we can see that 36 times 90 is 3,240 evenly with no remainder. Therefore, we know the answer to this one is 90. Okay, so that's that one. Again, in this example, we kind of used our answer choices to quickly solve this one. And again, there was no decimals here, so we know one of these was going to work out evenly. Okay, so that's that one. All right, number 9 says Dave borrowed $2,500 from his local bank. The yearly interest rate is 8%. If Dave pays the full principal and interest in the first year of the loan, how much money will he pay to the bank? So to answer this one, you have to know the formula for simple interest, and that's interest equals P times R times T, where P stands for principal. That's the amount you borrow in total. R stands for rate or interest rate, and that's always in decimal form. And T stands for time. So to answer this one, we have to figure out how much interest he owes for his 1-year loan, and then we'll add that to principal. So let's go ahead and do that. Let's start by plugging in what we know. We know he borrowed $2,500, which is going to be our principal here. We know he was given an 8% interest rate, so that's going to be in decimal form as 0.08. And we know the term of this loan was 1 year. Okay, anything times 1 is itself. So 1 times 0.08 is just 0.08. So we'll go ahead and drop that from our work here. So that's 2,500 times 0.08. And I'm going to work this off to the side so I don't make any mistakes. We're going to do 2,500 times 0.08. Again, we're doing multiplication involving a whole number and a decimal. As you know, I like to get rid of that decimal temporarily by shifting it to the right. In this case, we're going to shift it 2 times to the right to make this 2,500 times 8, albeit with 2 decimals to shift back into the left when we're done. Let's work this out. 8 times 0 is 0. 8 times 0 is 0. 8 times 5 is 40, so we bring down a 0 and carry a 4. 8 times 2 is 16, plus 4 is 20. Shift our 2 decimals back into the left. 1, 2. So in other words, 2,500 times 0.08 is 200. And that's the amount of interest he would have to pay on this loan for the year. That said, the question is asking if he pays back the full principal as well as the interest, how much is he going to pay in total? Well, we know he's going to pay $200 in interest, but we want to know what interest plus the principal is going to be. Well, interest is 200 and principal is given to us as 2,500. So we know that's 2,500. 2,500 plus 200 is going to be $2,700, which is C. Again, whenever you take a loan, you have to pay back the principal, which is the amount you borrow, plus the interest accrued, interest plus principal. Okay, so that's this one. 10 says Karen is training for her upcoming track meet. She makes 3 practice runs in a 1.5 hour time period. She runs 3/4 the distance of each previous run. If she ran 5 miles on the first run, how far will she go on her third run? So for this one, there's nothing too difficult about solving it. That said, there's a lot going on in this problem. Let's start with what's given. We're told in her uh, first run, she went 5 miles. That said, we're told that she runs 3/4 of the distance of each previous run. So that means in her second run, she's going to go 3/4 the distance of 5 miles. And in her third run, she's going to go 3/4 the distance of what she ran in her second run. So we're going to have to do quite a bit of arithmetic to go from 5 miles to the amount she ran on her third run. So let's go ahead and do that. Again, you would multiply 5 by 3/4 if you want to work with fractions. But again, you should know that 3/4 is the same as 0.75. And since we're working with decimals a lot today, let's just keep that trend going. So to go from her first run to the amount she ran on her second run, I'm going to take 0.75 and multiply it by 5. Okay? And as we know, when we're working with decimals, we want to take that decimal place and shift it however many times we need to the right to get rid of it. In this case, to make 0.75, 75, we shifted it 2 times to the right. So this is going to be 75 times 5, albeit with 2 decimals to shift back into the left at the end. So let's work this out. This is 5 times 5, which is 25. Carry a 2. 7 times 5 is 35, 36, 37. Shift our 2 decimals back in. 1, 2. So we can see that on her second run, she ran 3.75 miles. In order to figure out the distance she ran on her third run, we're going to take 3.75 and multiply it by 0.75. So that's going to be 3.75 times 0.75. Again, we're working with decimals now. So again, the key is to get rid of the decimals by shifting them to the right and then shifting them back in to the left when you're done. So I'm going to shift the decimal 2 times there and 2 times there. So in total, I'm going to shift the decimal 4 times. So this becomes 375 times 75, albeit with 4 decimals to shift back into the left at the end when we're done. 5 times 5 is 25. So we're going to drop down a 5 and carry a 2. 7 times 5 is 35, 36, 37. Drop down a 7, carry a 3. 5 times 3 is 15, 16, 17, 18. Before we start multiplication with this 7, we have to bring in a 0 placeholder here. And now we can proceed. We have 7 times 5, which is 35. We're going to carry a 3 now. 7 times 7 is 49, 50, 51, 52. Carry a 5. 7 times 3 is 21, 22, 23, 24, 25, 26. Let's go ahead and add these up. 0 plus 5 is 5. 7 plus 5 is 7, 8, 9, 10, 11, 12. Carry a 1. 8 plus 2 is 11 plus 8 plus 2 is 10 plus 1 is 11. Carry a 1. 6 plus 1 is 7 plus 1 is 8. And then 2 plus nothing is 2. Shift our 4 decimals back in. 1, 2, 3, 4. And we can see that in total, on her third run, she ran 2.81 miles. Again, we're just going to drop off this 0.25 since our answer choices only went 2 decimal places. So the answer to this one is A. Got a lot of work, nothing too difficult, but very tedious. All right, number 11 says, if the ratio of men to women in a city of 54,000 people is 3 to 1, how many women are there in the city? So you might be thinking you're going to use a proportion to solve this one, and you'd be correct. That said, it's going to take a little bit of logical thinking to set this proportion up correctly. Again, we're told that the ratio of men to women is 3 to 1. So let's imagine we're in a room and the ratio of men to women is 3 to 1. That means there's 3 men and 1 woman. As we can see, there are 4 people in this room. So that means in this room, there are 3 out of 4 men and 1 out of 4 women. We can't use this 3 to 1 to set up our proportion, but that said, we can use the fact that the ratio of 3 to 1 means that there are 4 people in a room, 3 of them are men, and 1/4 of them are women. So let's go ahead and use that proportion to set this up. Again, we're going to do 1/4 equals, and we're going to do how many women are in the city. Again, we know this 1 refers to the 1 woman in this room of 4. We're going to extrapolate that to be the whole city. So this is going to be X women in a city of 54,000. Okay. Now we can just cross multiply, notably X times 4, which is 4X, and then 1 times 54,000. Anything times 1 is itself, so this is 54,000. And all we do is have to divide both sides by 4 now to get X by itself. This crosses out and leaves you with X equals 54,000 divided by 4. Again, we can treat this as long division if we want. 54,000 divided by 4. Now the question is, how many times does 4 go into 5? That's 1 time, given that 4 times 1 is 4. 5 minus 4 is 1. We're going to drop down this 4 now. 4 goes into 14 3 times without going over. 4 times 3 is 12. 14 minus 12 is 2. Let's go ahead and drop down a 0 now. And we can actually drop down all of these remaining zeros if we want. Because if we think about it this way, 4 goes into 20 5 times. Therefore, 4 goes into 2,000 500 times. Okay, so 4 times 500 would be 2,000. 2,000 minus 2,000 is 0. So we can see that the answer to this one is 13,500. In other words, 13,500 women are in this city of 54,000 if the ratio of men to women is 3 to 1. Okay, so that's that one. Pretty challenging because you had to think about it logically. Again, I try to imagine that we had a room of 4 people. 3 of them were men, 3 out of the 4 of them were men, and 1 out of the 4 were women. Okay, so again, sometimes you have to do that. All right, number 12 says, 2 trains starting at the same station head in opposite directions. They travel at the rates of 25 and 40 miles per hour respectively. If they start at the same time, how soon will they be 195 miles apart? So for these problems, I like to make a little illustration as to what's happening. You have one train going this way, and we'll say this one's going 40 miles per hour. You have another train starting at the same point and going the opposite direction, which is this way, and it's going 25 miles per hour. The question is, how long will it take them to be 195 miles apart? Okay, so whenever you have trains or any object going in opposite or the same direction, what you want to do is imagine a third train going the same 195 miles, uh, albeit at a combined rate of these two trains. So 40 plus 25 is 65 miles per hour. And by working out this math with this third train, you'll get the same answer as if you work these out separately. So let's go ahead and see how we can work out this bottom scenario. Again, we have all the elements of the distance formula. The distance formula says distance equals rate times time. We know what our distance is. Distance is 195 miles. In this case, we're using a combined rate of 65 miles per hour. And we want to know how long it's going to take them to cover that 195 miles. So what we're going to do is solve for t, which means we're going to get t by itself. So we're just going to divide both sides by 65. This is going to cross out here, leaving you a t over here. And as we can see, 65, we have 195 divided by 65. If we were to round down 65 to 60, 60 times 3 would give us 180. Well, with that 5 remainder, we have 60 times 3 is 180. 5 times 3 is 15. 180 plus 15 is 195. So we know this is going to be t equals 3. And in math, it's customary to write the variable for which you solved on the left. So this is t equals 3 hours. Okay? Again, you could have worked this off to the side like this, 195 divided by 65, and then you could have used your answer choices to say what times 65 will give me 195, but this one's pretty easy to do mentally. Again, 60 times 3 is 180, 5 times 3 is 15, 180 plus 15 is 195. Okay, so this one is B, 3 hours. I have a whole video on distance, rate, and time. It's actually one of my more popular videos. So if you need more practice with these scenarios, just check out that video. Again, the link's going to be in the description of this video. All right, number 13 says a pizza maker averages making 14 pizzas per hour. At this rate, how many hours will it take him until he's made 840 pizzas? So to solve this one, we're going to set up a proportion, and that proportion is going to look like this. We're going to have an equal sign and two fractions that are equal to each other, and we're going to fill in this left-hand side with the information that's given. We're told the pizza maker can make 14 pizzas per hour. So let's fill that in accordingly. Again, we know he makes 14 pizzas every 1 hour. And we want to know how many hours. So I have hour in the denominator on this side. Let's keep hour in the denominator over here. And that's going to be X hours till he makes 840 pizzas. Okay. So as we know how to solve proportions, the next step is to cross multiply. You always want to cross multiply starting with the unknown value, so it's on the left side of your equation. So we're going to do 14 times x to start. That's going to be 14x. And we're going to drop our units, notably pizzas and hours. And then we're going to do 1 times 840. Anything times 1 is itself, so this is 840. Now we're going to divide both sides by 14 to get x by itself. And this becomes x equals 840 over 14, or x equals 840 divided by 14. And now we're going to have to use some logic to figure out how to do this one. Again, Again, let's just go ahead and think about how many times 14 can go into 84. We can see that our answer choices start with 6, 7, and 8. I know. Let's round this down to, or let's round this to 15. 15 times 8 would be. Let's work that out real quick. 15 times 8 is going to be 8, 9, 10, 11, 12. 15 times 8 would be 120. Therefore, 14 times 8 is going to be close to that. So we know 15 or 8's not going to work. Let's 15 times 7. 7 times 5 is 35, carry your 3. 7 times 1 is 7, plus 3 is 10. So 14 times 7 is going to be close to 105. We know those answers aren't going to work either. Therefore, logically speaking, we know that 14 times 60 must equal 840. Let's just go ahead and work that off to the side. We have 60 times 14. 0 times 4 is 0. 6 times 4 is 24. Add a 0 placeholder before we start multiplication with this 1. 1 times 0 is 0. 1 times 6 is 6. 600 plus 240 is 840. Therefore, we know 14 times 60 is 840 with no remainder, which means it takes this pizza maker, not 840 there, 60 hours to make 840 pizzas. If you're not sure what units to put, just look back up at your original proportion. We can see X goes with hours. So this is 60 hours to make those 840 pizzas. And we solved it using this little proportion here. Okay, so let's move on to number 14. Number 14 says Heather wants to purchase a pet from her local pet store. The pet store is offering 50% off rare exotic parrots. The original purchase price of a parrot is $956.50. Heather has a coupon for 10% off her entire purchase. How much will she pay if she also purchases a bird cage for $47.05? So the first thing we have to do is figure out what 50% of $956.50 is. So that's going to be $956.50. We're going to take 50% off of that, and that's going to be times 0.5. Again, the decimal form of 50% is 0.5. By working out this arithmetic, we'll know what half off of $956.50 is. So let's go ahead and do that. Again, we're multiplying decimals, as you can see, so let's shift the decimal in this one 2 times to the right, and in this one 1 time to the right for a total of 3 places. So this becomes 95650 times 5, albeit with 3 decimals to shift back into the left when we're done. 0 times 5 is 0. 5 times 5 is 25, carry your 2. 5 times 6 is 30, 31, 32, carry a 3. 5 times 5 is 25, 26, 27, 28, carry your 2. 9 times 5 is 45, 46, 47. And my pen is starting to act up a little bit. Let's shift our 3 decimals back in. 1, 2, 3. So we can see that half of 956.50 is going to be 478.25. Okay. Then we know that Heather bought a bird cage for $47.05. So let's go ahead and add that in. Again, that's $47.05 to find out how much she paid in total. Again, we're adding decimals now, so we can just bring it down in place. 5 plus 5 is 10, so we bring down a 0 and carry a 1. 2 plus 1 is 3. 7 plus 8, 8, 9, 10, 11, 12, 13, 14, 15. Carry a 1. 7 plus 4 is 11. Plus 1 is 12. Carry a 1. 4 plus 1 is 5. So in total, she spent $525.30. That said, she has a coupon for 10% off her entire purchase. So now we got to take an additional 10% off this 525.30. And that's not that hard to do. Let's work that out. This is 525.30. And we want to figure out what 10% of that is. So we're going to multiply it by 10% in decimal form, which is 0.1. Now we're doing multiplication involving decimals again. Let's get rid of those decimals. We're going to shift this one 2 times to the right. My pen is starting to die on me here. We're going to shift this one 1 time to the right. So this becomes this 525.30 times 1, albeit with 1 plus 2 are 3 decimals to shift back into the left at the end. 1 times 0 is 0. 1 times 3 is 3. 1 times 5 is 5. 1 times 2 is 2. 1 times 5 is 5. Shift our 3 decimals back in. 1, 2, 3. So this is the 10% discount, 52.53. And we got to subtract that from 525.30. So that's going to look like this. 525.30 minus 52.53. 0 minus 3 we can't do. And again, we're subtracting decimals here, so there's nothing to shift. We can just bring it down in place. 0 minus 3 we can't do. So we're going to have to borrow. This is going to become 2, and this is going to become 10. 10 minus 3 is 7. 2 minus 5 we can't do, so we have to borrow. This becomes 4. This becomes 12. 12 minus 5 is going to be 7. And 4 minus 2 is 2. 2 minus 5 we can't do. We have to borrow. This becomes 4. This becomes 12. 12 minus 5 is 7. And then 4 minus nothing is 4. So this is 472.77. I don't know why that 3 is there. It shouldn't be there. It's probably a typo. So this one's 472.77. Okay? Again, a lot of arithmetic to this one, but nothing too difficult. All right, number 15 says Andy is making an exercise plan. Specifically, he plans to walk a trail near his home 20 times per month. If it takes him 40 minutes to walk the trail, how many hours will he spend walking it each month? Okay, so for this one, we're probably going to have to convert minutes to hours and minutes. So let's go ahead and do that. The very first thing I'm going to do is find out how many minutes in total he walks this trail. We know he walks the trail 20 times for 40 minutes each walk. So that's going to be 40 times 20. Let's go ahead and work this out. 0 times 0 is 0. 4 times 0 is 0. Before we start multiplication with this 2, we have to add a 0 placeholder. 2 times 0 is 0. 4 times 2 is 8. 0 plus 800 is 800. So he spends 800 minutes walking this trail. Now we have to convert these minutes to minutes and hours. And the way we're going to do that is by taking 800 minutes, and my pen's still acting up a little bit. We're going to divide that by 60, since there are 60 minutes in an hour. Again, that's a conversion you have to know for the ASVAB. 60 minutes per hour. So again, 800 minutes to hours, we got to divide by 60. And let's go ahead and do this. Question is, how many times does 60 go into 8? It doesn't. How many times does 60 go into 80? That's going to be 1 time. 60 times 1 is 60. Again, 80 minus 60 is 20. And now we can drop down this 0. And the question becomes, how many times does 60 go into 200? 60 times 3 would be 180. 60 times 4 would be 240. So this is going to be 3. 60 times 3 is 180. Again, 200 minus 180 is 20. And again, we can place a decimal here as well as many zero placeholders as we want. Again, once we place that decimal, we can bring it up here, and then we can drop down a 0. Question is, how many times does 60 go into 200? Again, we know that's 3. 60 times 3 is 180. 200 minus 180 is going to be 20. Drop down another 0. And as we can see, this is going to repeat infinitely. This is going to be 13.33333. And we should know that 0.333 is the same as 1/3. So this is 13 1/3 hours, which is answer choice C. Okay. All right, so that's that one. Again, to go from minutes to hours, you divide by 60. To go from hours to minutes, you multiply by 60. All right, number 16 says Tommy is ordering concrete for a construction project. The price of the concrete is 0.02 or 2 cents per pound. Concrete is also taxed at a rate of 3 cents per pound. If Tommy needs 1 ton of concrete, how much will he pay? Okay, so first we have to know 1 ton is the same as 2,000 pounds. And we know the concrete itself is 2 cents per pound, and it's taxed at a rate of 3 cents per pound. So in total, he's paying 0.05, which is 5 cents per pound for this concrete. Again, that's the cost of the concrete plus the tax for the concrete. And now to solve this one, we're just multiplying a whole number by a decimal, which we've done quite a bit in this video, if you made it this far. Again, I don't like working with decimals, so I'm going to shift this decimal place 2 times to the right, and I'm going to take note of that. So this becomes 2,000 times 5, albeit with 2 decimals to shift back into the left when we're done. 0 times 5 is 0, 0 times 5 is 0, 0 times 5 is 0, 5 times 2 is 10. Shift our 2 decimals back in, 1, 2. We can see that this is simply $100. Okay, so that ton of concrete is $100. All right, so that is it for this video. I hope you found it helpful. In all honesty, a lot of the concepts you saw in this video may show up on the ASVAB. Again, as I mentioned, you're going to have to use proportions to solve a few problems on the ASVAB. You're going to have to know the distance formula and so on and so forth. As always, you're more than welcome to leave feedback in the comment section below. And if you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.